Hello guys, welcome to my channel Tech with Kazim. So today I want to look at how you can install and configure Suricata in Ubuntu. So I'll be using Ubuntu 22.04. So Suricata is used for IDS, intrusion detection systems, and could also function as an IPS, that's the intrusion prevention system, and could be used as a network security monitoring. So Suricata is an open source tool developed by the Open Information Security Foundation (OISF), and it's a similar to what you do with Snort. Suricata is also powerful and can actually be used for IDS to monitor your networks or any other thing you want to use it for, like to interface it with AI for anomaly detection. So it uses signatures, rules and signatures to be able to match rules and to alert if there's a rule match. So I'll be dropping this link for the Suricata documentation page. You could easily follow through to actually install Suricata on your system, and it's pretty straightforward, and it has detailed information about the signatures, how you can use the rules, and any other dependencies for Suricata you need to install. So first, I'll be using my Oracle VirtualBox VM, where I have my Ubuntu installed on it. All right, so I've got the Ubuntu up and running right now. So I'm going to launch the terminal. Yeah. So the first thing I just want to do is to check if Suricata is installed. Was that type Suricata, so not found. So what I'm going to Alright, so the first thing I'm going to do now is to install Suricata. So on the documentation page, so you can actually use this code to install Suricata and JQ. So JQ is a tool that allows us to display the if.json log file. So I'm going to talk about that later as well. So copy the code and paste the code here to install Suricata. So I'm going to say yes. So give it some few seconds and it's going to install Suricata on the system for us. Alright, so right now we're done with the installation of Suricata. So can use this code sudo suricata build info to actually check if Suricata is running or already installed the system. So I'm going to use this code now. Right, so when you receive the manual information about Suricata, so you should know Suricata is running and installed for us. Yeah. So the Suricata is actually installed. If you run which Suricata, so the user bin, where is yeah, so if you run where is, so right now if you run where is Suricata, so the Suricata configuration is actually in the etc folder here, this etc folder. So let's navigate to the etc folder. So I'm going to change the directory to etc Suricata. Right, viewing the information there. So we have this the YAML file. This suricata.yaml file is where you find the configuration for Suricata. But before we change anything or view the file, it's a good idea to back up that file in case you mess up the file. You can always revert back to the default file. So first, let's back it up right now. So I'm backing it up here. So I'm going to call it backup. Alright, so viewing the file now. Right, so we have this backup here, but this one I'm going to view right now to see the configuration for Suricata. But before that, I want to launch another instance of the terminal. So launching another instance of the terminal right now to actually see the network interface on the system. Right, so I have the ENMP OS 8 which I want to listen on, and it has the IP address 192.168.0.151 on the subnet max of 24. So I'm going to be using the ENMP OS 8. So right now, so let's view the configuration file for Suricata. So I'm going to be using Nano to open that configuration file. Using Suricata and suricata.yaml. Alright, I'm actually in this part, so actually don't have to do this. So just open suricata.yaml. Right. Yeah, so this is the configuration file, and it contains the settings for the Suricata configuration. But right now, you can see you can pass it the IP address range you want Suricata to listen on. Right now, I don't, and you can delete this and type in yours, or you can just append it. So what I just want to do is just to add this, like this IP address I show you is on the 192.168 range, 192.168.0.0 range 24, so subnet mask of 24. So I can just add that here. I can just come to the end here, or anywhere that's con con convenient. So I'm just add 192.168.0.0/24, and I want to add the 10.0.0. So you don't have to do this, but I'm just in case you need to work with that IP address range as well. Right, so but the one we'll be using is this one, this 192.168.0.0/24. So that's including that in our home network, the IP address range in the home network. You can just, since you're pretty sure which one you want to use, you can append it this way, or you can just remove them totally. And you can as well append it. So depend what that's good for you. All right. So the next thing I want to do is, if you scroll down to, there is a variable called AF packets, or we can just do a search with Ctrl W and type in AF packet, then hit on enter, and it takes us there. So here I want to specify the network interface that I want Suricata to listen on. If you look at here, you'll see that this IP address is on the network interface EMP0S8. This IP address I'm going to listen on. So I'm going to change this to change it to EMPOS8. EMP0S8. Right. So that's where you set which network interface you want Suricata to actually listen on. And so another thing is, if you go to the rule files, at the rule files you can set, like when you install Suricata, it comes with some rules set, especially when you use a Suricata update. Some rules, default rules that you can use with Suricata for monitoring, for detection, or you can specify your custom rules. So in this video, we're going to be specifying our custom rules, and I want to add that to the rule files. Let me search rule files. No. So I want to search rules, rule-files. Yeah, so here is the default Suricata rules, and it's at the default part, valid Suricata rules at that part. So I'm going to be adding some custom rule files. I'm going to create that file later, but I just want to add it here. So I'm going to add this file later. I just want to create it right now, so I'll call it custom.rules. So we're going to create this custom.rules file later that we'll use for our custom.rules. And in the meantime, since I do intend to use the default rules, I can just comment it out. Alright, so that's it. We've set the custom.rules that we'll use later for the default rules, and we've set the IP address range. We've set the network interface we want Suricata to listen on, and so it's a good idea to always have the backup of these PF record to use with multi-PF.ring support. So I can also just change this if you want to the network interface we'll be using EMP0S8, and the same here. So this from netmap. If you're using netmap as well, it's is available there. Then you can specify the interface you want it to. But the basic things that we want to do right now is to use Suricata as an IDS and also to use it as an IPS. First, we use it to capture some ICMP packets and some HTTP, TCP packets. Then we'll move on to now see how we can block incoming packets that's using Suricata as an IPS. Then, so I'll just write out this file. I think done with any settings, I the basic one. So we'll come back to this file when we're trying to use our Suricata for an IPS. But for now, it's good for us. It's okay this way, so that we can use it as an idea. So I'm just trying to see if there's nothing that is left out that we need to configure before we can use Suricata as an IDS. So there are some options that are actually turned off here that if you want to use them, you can just come here to turn them on, or you can just use the default setting as it is, as long as you specify the IP address range, the network interface, most especially that you want to be listening on. So it's good. So I'll just write this out to save it. Right. So we have our configuration rules added. So where if you look at this, you'll see that in the etc Suricata, we should have it in the rules file. But if you go to so if you go to values, just clear the screen here. If you change directory to var lib Suricata, so checking the value, I found out that there is no Suricata folder, so I'm going to be creating a Suricata folder in the value. So I'm going to create the custom.ru files there now. So now we have the custom.rules file there right now. So first thing I want to do is to test the Suricata configuration before adding any rule or working with it. So I'm going to open a new terminal here. So to actually start the Suricata, so we can use restart or we can use the tested Suricata configuration. So I'll just say sudo Suricata -c. If you say to specify the configuration file for Suricata, Suricata.yaml, specify the network interface now, ENMP0S8. So when you hit on enter here, Yeah, so it's kind of working. So if there are any issues here, you get some issues like maybe there's an error or something is not working fine. But the only issue we have here is that no rule files match the pattern invalid Suricata rules custom dot rules. So I'm going to look for this right now. So I need to have a rules folder there. So I'll stop this. So in the valid part now, just do ls here. So I have to do I have to create a folder and call it rules. Yeah, so in the rule files, you just have to move custom rules and move it to the rules folder. Alright, so I'm just going to sudo it. Right. So when you run an ls now, so we have a rules folder. So if you view the content of the rules folder here, so we have the custom rules. So we're going to have to check the configuration for Suricata again. Let's test it. Yeah, so it's working right now. So, but the only issue we have that we have one rule file specified, but no rules were loaded. Great. So now we'll just go ahead to add some rules so that we can start to use Suricata. Alright, so before I go on that, so this is an example of a rule that we can add in the custom.rule files. So the rule is just since Suricata is an IDS, so and it uses signatures to actually match a packet for a particular rule so that you'll be able to use it for monitoring purposes. So the rule takes kind of format like this. Like look at the HTTP. So look at the example I have here, the alert. So the alert is the action. So it starts with the action, like what you want to happen, and there are other actions that we'll see later, like you can block a packet, you can reject it, you can drop it, or you can just alert just to notify. Look at the example of the rule that we have here. So this kind of the rule we'll be writing in the custom.rule files. So this rule basically is just alerting, and so that is the action there. So we have several actions that could be used, like to drop a packet, to reject it, but in this case we're just alerting. And the protocol being used here is the HTTP, and meaning we're trying to monitor outgoing packets from this home network. That's why the source there is a home network, which is the IP address range that was specified in the Suricata configuration file, or it could be another IP address depending on the outgoing packet that you want to monitor. Now the next thing is the port, the source port, right? The originating port of the packet. So in this case, we're saying from any port. You could as well specify the port, maybe ICMP port or port 80, port 443, or port 23, or whatever port, or you can just say any port. Now look at the arrow. The arrow specifies the direction of the traffic of the flow of the packet. In this case, it means outgoing packet. It means you're trying to use Suricata as an IDS from the home network. That's the source network, source packet. Then you're trying to monitor any traffic, any packet directed to the external network. So the external network will be the destination IP address range, or destination IP address, or the destination domain name. Then in this case, we're trying to capture those packets on, or to monitor those packets on any port as well. Then there's the rule options. So you can have rule options for your rules, like the message, like maybe when you alert or you capture that kind of packet, or you dictate that kind of packet. So the message you want to display. In this case, I just have a request there. Could be HTTP request. Then in the rule option, you also have the signature ID. So you have to get because in your custom.rules file, we might have a lot of rules that will be written down. We'll see that later. So you can give them a unique ID that can differentiate them from other rules. Then you can have the rev option as well, which is a parameter that specifies the first revision of this. Now, for example, if I'm monitoring outgoing and incoming packets to the home network, so I want to have a second rule as well that we now have to interchange the home network and external network, and I can say that's revision 2 or something. Or I'm just trying to monitor same source, same destination, but different ports. Then another monitoring I'm doing, same source, same destination, and another port again entirely. So I can say one is a revision 1, one is a revision 2. So this is the basic format of writing a signature rule that we're going to write later on here right now. So just to visualize things for us, let's say you have a client and you have a server that are communicating. In this case now, this is a two-way communication, right? Client sending a request to server and server sending a response to the client. You can see the IP address of the client is 192.168.0.1 on port 1024. Then for the server, it's 212.230.0.15 on port 80. So it kind of rule that if the first rule, like for outgoing packets from the client to the server that we can have here is, let's say you want to detect any TCP packets on that. So that's the rule we have: the alert, that's the action, the protocol TCP, then the IP, the source IP, which is the IP of the client, then the source port, which is 1024 that will have them. Now look at the direction, which is the forward arrow, which is the destination IP, which is the IP of the server. Then any traffic directed to port 80 of the server, then we want to alert incoming packet. I will give it a signature ID of 123 and a revision of 1. So we can have a second rule as well to now monitor from server to client. In that case, it will be alert TCP. Now the source IP now will not be the IP of the server, which is 212.230.0.15, and the source port will be 80. Then the destination IP will be that of the client, as well as the destination port as well. So just interchanging it. However, the arrow doesn't have to change, as we will see. As long as we've interchanged the source and destination, then it's fine. You don't have to change the arrow. So the arrow is always a forward-looking arrow that specifies the direction of the traffic flow there. So these are just some of the valid actions that could be used. So we can use the alert, and it's also in the Suricata documentation in the link that is in the description. So the alert is to generate an alert. Then you can also pass a packet, which is to stop further inspection of the packet, or you could drop the packet and generate an alert, or you could also reject, which is to set a reset or ICMP on reach error to the sender of the matching packet. And we can reject the source as well as reject the destination, or we can reject both. So now let's go back to the demo. Now let's go back to the Ubuntu. So let's add some rules in a custom .rule files. Right. Oh, sudo nano. Open up with nano. You can open it with any ID of your choice, but oh, there's something right here. Okay, so I'll just clear the screen. So I have the rules here. We have the rules. We have custom rules. Sudo nano custom rules. Yeah. So here, the first one I want to write is an alert. So the first rule that I just want to add there is to just alert, just to signify when to capture ICMP packet. Now the first rule I want to use to capture an ICMP packet. So I'm going to say alert, then specify the protocol ICMP. Then from any port, I'm trying to, or you can just say from port 23, but in this case, let's just say from any port. So we're alerting and capture ICMP packet. When you have the action, then you have the protocol. Then the next thing you want to have is you want to have the IP. In this case, let's say anyone originating from any, meaning from anywhere. Then we want to have it on any port as well. Then if the traffic is directed to our home network, so $home to our home net on any port here. So we can also add the option, the rule options. Let's add some messaging and call it incoming ICMP packets. So we can give it a signature ID. Let's give it 123 and a revision of 1. So just this rule. So here we're trying to monitor any ICMP from any network, from any port that is directed to our home network on any port here. Then once there's a rule match, then we want to dictate an alert incoming ICMP packet, and it has a signature ID of 123 and a revision of 1. So I'm going to write this out now to save it. Alright, so I have to exit this. So right now, I'll need to fire up the for the Suricata also, so we can monitor the log on the if.json log, or we use the fast log. So if.json log just have the log in JSON format, or the fast log just allow you to display the logs in a single line in your terminal. So we'll try and use the fast log for this. So for that we can do sudo. I can just open a new terminal for this so that I can easily come back to this part as well. So here now, the fast log could be found at the var log suricata. So if you change command to var log, so here we have the logs, we have the if.json log, we have the stats log. So there are a lot of logs there, and some of them you need to go to the Suricata configuration file to enable them, like the tls.log, http log if they're not enabled. But the one we want to use now is the fast log. So I'm going to add the fast log allow you to display the logs in a single line in the terminal, so you can monitor for to detect if there's a rule match right from there. So I'm going to do sudo tail so that I'm seeing the latest, whatever is detected, the latest one detected. So sudo tail, then fnf var log suricata and fast log. So okay, and the password. So as soon as we run this now, so the fast log is waiting to capture if there's anything. So we'll come here now since we have a rule in our Suricata, so just come here to start the Suricata again. So you can just say sudo suricata -c, then that's the configuration file. So you can just test it again now on that network interface. So so we have Suricata running right now. So I'm going to use I'm going to try and ping it from my base OS right now. Alright. So I'm going to try and ping that from my base OS right now. Right. So you remember Suricata is running and the fast log is also waiting to capture. So, and I have for my base OS, remember this is the IP address of the network interface we're trying to capture, 192.168.0.151, that is on this network interface. So I'm going to ping that right now. 192.168.0.151. So as soon as we ping it, and you can see the fast log instantly detected that, and uh, because it's been sent to Suricata and we have it captured in the fast log. And so if you look at this further, you see it captured right now, and that's the message, the rule option, the message we gave it, which is incoming ICMP packet. And you can see the priority level, which is 3, and the protocol is an ICMP. That's why it's able to capture it. You can see the destination IP, which is this, and this source IP is 192.168.0.128. That coincide with the IP address. That coincide with the IP address of my base OS. Right, so that coincides with the IP of my base OS, the 192.168.0.128. So it was captured. So, and basically that's how you use Suricata as that's how you can use Suricata as an IDS, basically. So now finally what we need to do now, so I'm going to stop this fast log and stop Suricata. So the next thing now is using Suricata as an IPS. So the difference between an IDS and an IPS is an IDS just monitor or detect, but an IPS not will monitor, detect, and also has the capability to block a packet, incoming or outgoing packet. So we can use it in combination with firewalls or other tools for it to work effectively. And also it's very efficient if any rule match as match. Maybe you want to block an outgoing an outgoing traffic, also incoming traffic. So what we're going to use, there are a lot of ways that you can use Suricata as that. And if you go to this link, also I've dropped this link also in the description, and it has some detailed information about how you can use Suricata as an IPS, and you can use it with a net filter. You can use it with IP tables, or use the NFQ, which we're going to use right now. So we're going to use it as we're going to use the NFQ to actually use Suricata as an IPS. So the first thing we need to do, we need to go back to the Suricata configuration file. But before you do that, there's one thing you need to check. You need to ensure that Suricata is has been set up to work with NFQ. And you can also use the previous command we use, Suricata --build -info. And if you scroll up here, yeah, so you'll see the NFQ support, and it's showing us, yeah, so Suricata is built for that. So we're going to use NFQ capabilities together with Suricata for it to work as an IPS. I've showed you there are other options that we could use, but for this tutorial we'll be using the NFQ. So we're good to go as Suricata is configured to work with NFQ. That's what we're going to use. So right now we'll go back to the configuration file. So I think I have the configuration file here. So is that we can open it with sudo nano etc suricata.yaml, the YAML file. So then what we need to do is when you scroll down to NFQ, so there's a variable called NFQ there where we can configure Suricata to work for you to work to use NFQ support and work as an IPS. Or you can just find it, Ctrl W, and just type NFQ, enter, then if you just scroll down a little bit here, then you see the NFQ support. So what we're going to be doing here is to uncomment, like this fields, these parameters are commented out. So we're going to uncomment it. The mode, you should accept it, and also the repeat marks. Then we should have the route queue. Now the route queue is, so you give your the like any of the rule you want to forward. So the way NFQ work is that you're forwarding all incoming packets to be routed through Suricata IPS before it gets to the destination. So at that point, Suricata does its job and check the rule. If it matches the rule, then it decides if to allow that packet to proceed further or to block it. So it's going to use that route queue to actually be able to also work with NFQ effectively. So we're going to recommend it just these four parameters, and that's all we need to do. Then we write it out, save it, and exit. So now we need to go and modify the custom rule files because I'm no longer in the directory, so I have to give the full path valid, then rules, then custom the rules. Oh no. So just change. So I have to go and edit the custom rule file. So just change directory to valid suricata/rules. Yeah, so I'm gonna open. I'll open the custom rules with nano right now. All right, so we can add the command. Now in this case, now we want to drop because the essence of an IPS is you know the capability of an IPS is not only to monitor and detect, but also having the capability to block or drop any packet that matches a specific rule. So here now I want to drop the ICMP packet, but I'll just comment this out. In the other case, we monitor detected the ICMP packet, but here we want to drop. So the action is alert. Then the what we're doing now is the action is drop. The action is drop, and what we're doing here now is for ICMP, which is a protocol we want to drop. Then from any network to any port, then that's going to, for this now let's use any, that's going to any, or let's say the one that is going to the home network, to any port, and let's just say just want to give it some rule options. So in this case we want to say drop ICMP packets, and okay, drop ICMP packets, and we'll give it a signature ID. Let's give this 124, then revision 1. So we're dropping any ICMP packet from any network, from any port, directed to our home network on any port, and we're giving that message. So I'm writing this out right now, and as it. So we have the rules set there. So we need now to use IP tables. So I'm trying to use IP tables to be able to use do that. So we'll just guess I can use this. Right. So using IP tables now. So I'm going to do sudo IP tables and specify what we're doing. So now specifying the input, then the protocol -p to specify the protocol. In this case we're saying ICMP, then -j, then we're using NFQ. So this is for forward traffic, for the input, right? So and then we need to give the queue number. If you remember in the configuration file, we give the queue number as 2 in the configuration file. So our queue number is 2. That we give the queue num is 2. So this is for the input. So we're going to do same for the output. So I will just change this to output and P, same as ICMP, J NFQ, then the queue number as 2. So we've done that, and you can actually check the IP tables and see if that rule is actually added. So you can do sudo IP tables, VNL. So so you can see the rule there that we just added, NFQ, the ICMP with the NFQ number of 2, and that's it there. So I think that's it for that. So the next thing now, we just have to run Suricata to actually capture traffic there. So here, but what I'm going to do is I'm going to give the queue num, since we're using queue number of 2. So I'm modifying the command to start the Suricata for IPS mode as sudo suricata -c from the etc suricata.yaml, then -q, then 2. So run it. The another thing is to run the fast log. Running the fast log. Right, so run the fast log here. Right, so we have Suricata running and the fast log here. So we might not see anything being logged there because we're just dropping the packet. We're not allowed. What I'm going to do is I'm now going to initiate the packet again. Right, so I'll just clear these. Right. So for this time around, I want to ping it. I want to send 5 ping packets to it. So you'll see this time around I'm getting access denied, or if you ping it either way, request timeout, right? So you get dropped, and you see request timeout, and it get dropped right now. So and you can see there it has been dropped. The ICMP packet was actually dropped there. So it timed out and it dropped, and you can see that you have 100% loss. So this is how you can use Suricata as an IPS mode. So we've seen how you can configure it as an IDS. Then now you can also use it as an IPS as well. So, but now you can also remove the NFQ. Let's say you want to revert it back to delete forwarding of ICMP packets to the NFQ. So we just have to adjust our changes. So we'll just stop this first, and that's the last thing we're going to look at right now. So to stop to delete the forwarding rules from IP tables and allow that to work. So to actually delete that, so we're going to do sudo IP tables. Sudo IP tables, then we'll use -d, then we specify the input, then -p, since that's what we have there. You know, we saw it earlier, the NFQ ICMP that were added there, so we're trying to remove it right now. So -j NFQ NFQ and dash then the queue number. So the queue number has to match, which is 2. So we'll do that for the input, and we'll still do that for the output to delete that as well. So for the input and for the output. So if you check the IP tables again, if VNL. So you'll see that we no longer have the ICMP table there that is captured. So that implies that if you ping the IP address again now, you should be able to, it should pass through. It should pass through. So I'll start the Suricata, then I'll start the fast log. Start the fast log. Okay. Well, before starting the fast log, we just have to, yeah, we just start the fast log, yeah, either way. Though we don't have, I wanted to add a rule to, just alert the ICMP detected, but either way we can just start the fast log and just, see if we're able to ping it. Earlier we're having access denied or timed out. Let's see if we'll be able to ping it right now. So if we ping it now, so you can see we're getting some replies. So it's now working. So we have 0% loss right now. So I want to ping it with like 5. Let me see, 5. Okay, so let's just ping it this way. Yeah, so now we're able to ping it. So this is how you can use Suricata as an IDS, as an IPS. So I hope you enjoyed this tutorial, and I hope it helps you also in your project or whatever you're working on, that you can actually use Suricata as an IDS IPS, and so that you can keep monitoring for malicious or anomaly behavior. So thank you for watching this tutorial. See you some other time.